Welcome everyone to the Tulsa.net user group. Tonight, Tim Corey talking on understanding Blazor. Thank you all for coming out tonight. This is going to be a great talk. Tim, thank you so much for being here to talk about Blazor. I'll let you take it from here.
Sounds good. Thank you very much. So this is introducing Blazor. What we're going to do is go over a few different things, but we're going to try and start with PowerPoint. I hate PowerPoint, so we're going to be really quick in PowerPoint, but I wanted to give us kind of a baseline to go from. So this is going to be our agenda. We're going to talk about the introduction. That's this right here. The history of Blazor, just really quickly, so you understand it. Blazor terminology, just so we're on the same page with the terms I use. And then we'll get into the Blazor Web App overview, a Blazor WebAssembly overview, and the future of Blazor. Basically, what we're doing here is I want to get you through the basics. This is not a basics talk. This is not about, file new project necessarily. This is about kind of getting you into the Blazor projects and understanding it. But then what we're going to do is we're going to touch on some of the trickier bits, the bits that you go, wait, what is that? Or how does that work? Or why is that happening? So you have a better understanding of these projects, where they fit, whether you want to use them or not, and where they fit in your overall web app architecture. So with that, let's get started. Oh, questions at the end too. So I'll be available for questions both during the session and also after the session as well. With that, let's go with the history of Blazor. So the history of Blazor starts with Steve Sanderson. If you want to watch a fun talk sometime, watch Steve Sanderson give a talk on pretty much anything. The man has never learned that no is an option or can't be done. And so back at NDC Oslo in July of 2017, he had this little demo that he came up with, which basically was Blazor WebAssembly. So what it was he took the mono runtime from .NET and put it into the browser and said, hey, can I run .NET on the client? And the answer was yes. And that was, again, 2017. Out of that, or as a result of that, 2 years later, in .NET Core 3.0, we got Blazor Server, which is not the same thing. Blazor Server, and we'll talk more of this in the terms, but Blazor Server is the idea that you have all of your code run on the server, but yet you have a SignalR connection to the client. And what that does is it allows the rich client-side interactivity of, say, an Angular Reactor View, but yet all of your code stays in the server. So if you're familiar with Angular Reactor View, all of your JavaScript goes to the front end. So it all goes down to the browser and then it gets run in the browser. Well, with Blazor Server, that's not what was happening. What was happening was all of your C# code stayed on the server, and yet the SignalR connection, which is just basically WebSockets in the background, is connecting to the clients and saying, hey, here's the new things that show on this page. Hey, here's the new things to display. And that was the start of the official Blazor story. Next up, which came kind of out of band, this is when they started to kind of clean things up and move to a regular cadence for .NET. But out of band came Blazor WebAssembly with .NET Core 3.1. And this is in May of 2020. So Blazor WebAssembly, again, was more of what Steve Sanderson was doing originally, which is take a version of .NET, the entire version of .NET, but crunched down, and send that down to the client as part of the client-side code. And all your C# code that you wrote also went to the client. And it acted the same exact way as a Angular Reactor View, in the fact that your client-side code fully ran on the client. So that was the kind of second crack at Blazor. So they had two different versions of Blazor for a while, Blazor Server and Blazor WebAssembly. I say for a while because they still exist, but we'll get back to that in just a minute. So with .NET 7, we got Blazor Hybrid. Now, if you're familiar with .NET MAUI, MAUI stands for Multi-Application User Interface, I believe. Basically, MAUI is the old Xamarin merged into .NET, And so what it allows for is native desktop applications on Windows and Mac, and then native uh, applications on the phone for iOS and Android. And with Blazor Hybrid, what they did is they said, hey, we could run Blazor code in a web control, but it's native. So it's not actually going to the server to get the code. There's no server involved. It's actually running locally and natively on that device, but it is running using a web control. So that's Blazor Hybrid. Basically, if you want to run a .NET MAUI app, but you're familiar with Blazor or you have a lot of code in Blazor, you can look at Blazor Hybrid. We're not going to touch on Blazor Hybrid in this talk. It's just too much to cover in a short amount of time. So I will talk about it, but we're not going to actually see it tonight. So next up is Blazor Web App with .NET 8. This is, in my opinion, the culmination of Blazor. Sure, there's more to do. There's more things to add, more things to tweak, and more things to get right. But with .NET 8, what they did was they took Blazor Server and Blazor WebAssembly and said, hey, what if we just mixed those together, shook them up, and made one project type out of it? And so that's what we have with Blazor Web Apps. Basically, what you can do is you can take your web application and have multiple states inside of one application. You can have fully server side, which is kind of like what MVC does or Razor Pages, but then you can kind of transition into somewhat client side using some Blazor server technology and having that streaming connection, but only for certain components. And then you can also go to Blazor WebAssembly for some components where it runs on the local machine. And you can kind of mix and match your site with this. We'll see more about this, but this is my favorite by far of the Blazors because of the fact that it allows your application to grow and change over time as you want it to. So you can start off with one idea of what your web app might be, but then say, hey, you know what? This piece would be better if it was a different style, if it was a just server side rendered, or if it was, much more client interactivity. And so the Blazor web app was that combination of all of those. And just to be clear, there is still the templates for the other types should you need a specific, just Blazor WebAssembly, which we'll look at tonight because there is a reason to use at least the Blazor WebAssembly project type still. So that's the history. Let's jump right into some terminology. Again, just kind of level setting here to make sure that we all are on the same page. ASP.NET Core, if you're not familiar with the whole .NET naming, .NET naming is a whole, from the outside perspective, it's a very confusing mess. Now, there's a very good reason for all of it, and I actually believe they made the right choice on pretty much all the naming. But it's hard, right? We've had .NET since 2001, 2002 era, and things have changed over that time, and they kind of reinvented things with .NET Core. ASP.NET Core is the right terminology for .NET. So we have .NET, used to be .NET Core, but now it's just .NET. Well, it uses ASP.NET Core. So just to be clear there, that's the .NET web framework. So ASP.NET Core is kind of the back-end framework or the background framework that powers the different web application types, which means that even in your Blazor app, you could have some MVC bits or some Razor Pages bits if you wanted to. I don't see the need for that necessarily, but what you'll see is if you're familiar with one of the web project types, you pretty much know how the structure is going to work for the others. That's the background power of all the web projects. Okay, SignalR. If you're not familiar with SignalR, by the way, I have a YouTube channel. I'll link it at the end. If you're confused on any of these topics, I have YouTube videos on pretty much all of these that go into more depth so you can understand what these are. I'm just skipping over the top of the water here. But SignalR is basically a wrapper around web standard technology. It is not really anything new except for on top. What it does is it handles the connection between a client and a server for real-time communication on the web. And it does so primarily through WebSockets. Now, it has code in there for, server-side calls and also long polling should your browser not support WebSockets. So it can do some fallbacks there, which pretty much don't need to be done anymore. but this allows for some really good added technology around the signal, around the WebSockets experience. So SignalR is what Web or Blazor Server uses for that connectivity. Blazor Server, we talked about, it's the fully server-side rendered, except for the fact that it has connection via SignalR to the client, so you can see some rendering on the client that looks like it's client-side, but your code stays server-side, which means it's still protected, and you can do things like talk directly to databases and other things without having a security issue with the client seeing it. Progressive web applications. This is where Blazor WebAssembly standalone projects are so awesome, is they allow for a progressive web application. If you're not familiar with PWA, what it does is it allows you to install a web app on your phone, on your tablet, on your desktop, anywhere pretty much, and it will run as if it's a native app. It's not a native app. It's still running a website or a web application, but it can run offline. It can store data locally. It can do a bunch of other things, but it runs what's called a headless browser. So it's still running in a browser, but you don't see things like the back arrow and the URL bar and all the rest. So you just see the application. All right, Blazor WebAssembly. This is what we can use to run a PWA. So Blazor WebAssembly fully runs on the client, as we talked about. Okay, .NET MAUI. Again, I explained that earlier. Blazor Hybrid, we talked about, that is running on .NET MAUI, but it's that web control that runs Blazor. All right, a static web application. The idea here is, you probably heard of Azure Static Web Apps. What they are is web apps that are typically HTML, CSS, and JavaScript, and they can run fully on the client. You don't have to have any server like running PHP or MVC to create the web pages that get to the user. You just have everything that can run client side. The good news is that Blazor WebAssembly can run as a static web app, which means it can run on very cheap hosting that runs around the world, and it can be very fast using a static web app, for example, on Azure. Server-side rendered. So we're going to talk a lot about server-side, client-side, and Blazor kind of says, hey, let's just blend all that together, which makes things a little interesting to talk about. But server-side rendered is what you'd get with MVC or PHP or other languages where everything gets done on the server. So you have your code on the server, but then it spits out HTML and CSS and gives that to the client. It's very fast, it's very performant, but it does depend on your server doing a lot of the work. Well, Blazor can do server-side rendering, and by default, it does that with Blazor Web Apps. So it does all the work for you on the server, sends down the code to the client as HTML and CSS. But again, Blazor's got some blending in there we'll talk about. Stream rendering. This is where, again, Blazor starts to cheat, which is awesome. I love the fact that it cheats. So what it's going to do is it's going to say, hey, let's do server-side rendering, but there may be stuff you're waiting on. No problem. We'll send it to you later. Even though it's doing it on the server, it's doing it later and then injecting that into your site, and we'll see that. Enhanced navigation, similar concept. Normally on a server-side rendered page, like again, PHP, when you go to a new link, it's going to refresh the entire page. But with enhanced navigation, Blazor says, hey, you know what? Normally we refresh the whole page, but what if we just refresh just the piece you need? And so it just refreshes the piece you need, making it a much more client-side feel while still being server-side. Hot reload, we'll see tonight, but hot reload allows you to do work in design time. So when you're building your application and you run your application, you say, oh, I want to tweak that one thing. You can do that while your application's running and not have to restart your application. Now, there's always edge cases to that, but as they have improved, hot reload's gotten better and better and better about more work you can do inside of your editor and have a hot reload happen versus having to do a full reload. And we'll talk about components. Components are the building blocks of Blazor. This is where, again, it's a really great concept where everything you do is a component. Everything you do can be put somewhere else. It doesn't have to be a full page that we're talking about. And so we're going to get into that. All right. That was super fast. That was a lot to see, and that was a lot of PowerPoint. And for me, that's all I got. Okay, we're gonna stop right there. The next slide is just for questions. Okay, so let's get right into the demo because I think this is where we have the most fun. So let's jump over to Visual Studio. I'm in the latest Visual Studio 2022. It's 17.4 maybe. I'm not positive. We can look in just a minute. But we're going to load up a Blazor Web App. Now, if we search here for Blazor, we'll see we have Blazor Web App, Blazor Server App, Blazor Server Empty or App Empty, Blazor WebAssembly Standalone App, and others. Now, we're going to focus tonight on Blazor Web App, which is that combination of everything, but then we'll also jump in briefly to the Blazor WebAssembly Standalone App, again, to see that progressive web application. Okay, so you're following along, Blazor Web Apps, where we're going to go. And we're going to choose, let's say Blazor Web App is a project name, and this is Tulsa user group demo. Okay. Now, this is where we get our questions about, hey, what do you want to do? And we're going to choose the latest, which right now is .NET 9. Quick point here, if you are wondering, should I use .NET 9 or is .NET 8 better or somehow more stable? No, use .NET 9. The question comes up sometimes with standard term support versus long-term support. The only difference in terms of support is how long the support lasts. That's it. They're both production ready. They're both ready to go. So .NET 9 will be supported for 18 months, I believe, from release, which was released in November of 2024, which means May of 2026 is when it goes out of support. Upgrades, super easy. Change the 8 to a 9, change the 9 to a 10. That's almost always all you have to do unless you have a lot of dependency issues. So we're not going to get into authentication tonight. We'll skip that very large topic. We are going to look here at interactive render modes. So this is where, again, Blazor does a lot of that mixology for you. And you can change this later, but I would encourage you to just leave it at auto. So server and WebAssembly, we'll talk about auto, what that means. But what this does, it sets up your template with all the stuff you're going to need, and you can go from there. As far as interactivity location, you can do per page or component. Leave that alone. Leave that there. You could do global, but you really want to have that ability to choose as you go what each component does as far as interactivity. We will use the sample pages because it's a great place to start. And this is confusing, but leave this box unchecked. Do not use top-level statements. This is for if you really love to see the in the program.cs, you like to see the namespace and the static void main and all the rest of that stuff. You could check that box, but personally, I think that program.cs looks a whole lot better and cleaner when it's just clean. I have a whole video on that discussing the pros and cons of that. And then we're not going to enlist Spire orchestration at this time. Okay, well, that's a totally different demo. All right, let's jump into Blazor. We've got a lot to go over, but let's just look at what we have out of the box. So out of the box, we get 2 projects. And the reason for this is because of the fact that we said auto. Now, if we'd said none or just server, then we would only have 1 project. But because we said auto, we get 2 projects. The reason for this is because remember that WebAssembly runs fully on the client. And because of that, we want to make sure we have a separate project. We can send just the WebAssembly bits down to the client. We're not sending our server bits. We're not sending our server-side rendered bits. We're just sending the bits that are going to be WebAssembly down to the client. So in this demo right here, that's the counter.razor. So this is the component for counter.razor. Notice it says that render mode is interactive auto. Because of that, it will go down to the client when it is in WebAssembly mode. Now, this component can do dual duty. It can do actually triple duty. It can do the server-side rendered version or the static version, and then it can do the server version, where it uses SignalR for connectivity. And then in the background, it will download the WebAssembly version of the same component and then switch over. That way you can have the fast load of Blazor Server and have that fast first interaction. But then the next time you can have the WebAssembly version, which is even faster now that it's downloaded because it's on your machine and it can be even faster. So because of that, we have to put it in the client version because of the fact that it will have a copy of it or a version of it that is WebAssembly. We also have up here components that are going to be for example, the weather and the home. Notice we have up here the render mode. There is no render mode here for home. That's because it just says, hey, we're just going to render this as a server-side render, kind of like PHP or MVC. Weather does have this attribute called stream rendering, which we talked about, and we'll see what that does. But basically, down here in this component, there is an await here. So we're going to wait half a second just to show you what's happening. And we'll actually extend that out. Let's make this 1.5 seconds or 1500 milliseconds. What it's going to do is load up the data, but it's going to wait to do that. So we're going to show off the fact that this page is going to render initially and then pull extra information from the server, even though it's a server-side rendered page. So we'll see that in just a minute. So let's run this project just to see how this looks and works, and they're going to start making some tweaks. Waiting for it. There we go. Okay, so we have our hello world. You've probably seen this if you've seen any Blazor demos. You've seen a hello world. If we go to the counter page, great. The counter works. We can click it. It increments. We go to the weather. Just watch the screen for a minute because when I go to weather, we're going to have that 1.5 second delay. So I go there and it says loading, and now it shows. Even though this is a fully server-side rendered page, that stream rendering says, well, actually, we're going to inject more information later into the page, and that's from our await. So right down here, we awaited that. It injected that later. So this allows you to, again, have a progressively more interactive site as you need it. Some pages you don't need interaction on. Maybe you have an about page. It's, about Tim and how awesome he is. That doesn't have to be something that changes all the time. It can be server-side rendered. Well, that'd be like the home page, right? It's just there. But then there are other pages you want full interactivity on. For example, like the counter pages here, where you can do things like, rich client-side interaction. That's where you might use an auto component. And then we have the weather, where it's like, certain pages might need to get data, and so it's going to take a bit to load, but they don't need to have interactivity. Therefore, we can just use the stream rendering. So let's take a peek right here at the counter, and we're going to make one tweak to this page. So I am going to, well, first I'm going to be a good web developer and say div with a class equals h2. In case you're not familiar, h1, h2 indicates a hierarchy in the page, whereas if you just want to look like an h2, well, in Bootstrap, which is what we're using, you can say just put a class of h2 there. So it's not actually changing the hierarchy. Not that it really matters, but I kind of want to make sure we do things the mostly right way when we're building. So what we're going to do is we're going to look at this command, render mode, and we're going to say, nope, render info. Thank you. I spelled that right. Render info.
Tim, we had a question that come in when
Yes.
you're ready for one.
Sure. Shoot.
Okay. Does the stream rendering automatically have a loading GIF, or do you need to implement something? Or
Good question.
How would we implement, how would we add our own loading images?
Excellent question. So this is where we had that delay and we had that just said loading dot dot dot. That's actually up here. So you could put your own GIF in there. You could put your own whatever you want to do in this section. And what it's doing is waiting for this forecast. When forecast is null, then show loading. And that forecast is what we're loading down here. So we're loading that and we have a delay beforehand. Therefore, when it starts off, it's null. So you can put whatever you want in that spot. Okay. So here I'm going to show the renderer.name. What this will do is it will show me where we're rendering this counter component, if it's on the server, if it's on the WebAssembly. Let's run this again. I want to show off how this works so you can kind of see the transition here. So you have to watch real quick, but if we click on counter, it says static, and then we have this unable to retrieve source. That's awesome. Unexpected. I'm pretty sure that's just a one-time bug, but let's rebuild and try it again.
I mean, what's a demo without a bug?
Absolutely.
There's no such thing.
I love live coding. Okay, counter. So it says server. So it went from static to server. So this component is using SignalR to connect back and forth. And if we, increment it's just fine. If I go to the home and come back to that counter, it says WebAssembly. So it's changed over. And now this is running as WebAssembly. And again, it still works the same way, but it's now running locally as opposed to having that SignalR connection. That SignalR connection is no more. It's gone. So there's two benefits here. First of all, that component, when it was running Blazor Server, it was just that component that was talking via the SignalR connection. But also, when we use the auto mode, it starts as Blazor Server, which is the very fast to load because it's rendered on the server and pushed down. But then in the background, it downloaded the WebAssembly components necessary to then the next time I asked for it, even in this current session, it will give me the WebAssembly version, and I don't have to do anything to get that. Okay. So now there are some gotchas here, and we'll talk about those in a little bit. But this is what the auto mode does for us. It allows us to change in the background. So the user gets the best of both worlds, right? Blazor Server is very fast to load, and it's very fast to interact with because it's running on the server. But there is a limitation with that always on connection between the server and the client. Now, that limitation gets a little bit overblown as far as how scary it is. I don't find it nearly as scary as some people do because the fact that the connection is very, 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 very light. It's not nearly as heavy as people think it is. You can run 10, 15, 20,000 connections on one server and be just fine, which means 20,000 concurrent people before you start thinking about, hey, I should offload some of this to maybe the Azure SignalR service. But at the same time, having the browser always connected means that if you have an internet glitch, well, then you've got a problem. Or you have, something else happen, you've got a problem. But with this, we only had that connection as long as they had the component loaded the first time. After that, they don't use that connection anymore. It's all local, which means we had the best of loads fast, and now we have the best of loads even faster and doesn't need a connection the second time. So that's how this works. If we go to F12 and open up the dev tools and we look here at, I don't like when it does this. Let's pop this out. Okay. So in my dev tool, we can go over to the application and look at local storage. We see here in our local storage, we have some values. If we just clear this local storage value, if we come back to it, it's still going to say WebAssembly. But if we hit refresh, now it says server. Okay, so we cleared out the component out of the local storage, which means the next time you reload the page, it's not there anymore. But now it put it back there, and we're back to WebAssembly. So that is that is how the auto mode works. Again, big fan. My big thing here is that, for the home page, this is just statically rendered page. It's very, very fast to load. It's very fast for the client. And it's what a lot of web pages need. Not every web page needs to have full interactivity. If you think about, I don't know, the local pizza restaurant, right? Most of those pages don't need interactivity. Maybe the order page needs interactivity. Otherwise, you just don't need it. So this is where this can allow you to expand your site over time. We could add interactivity to this page just by adding this interactive or render mode. Now, since the home page is in the main project, well, we'd have to say only server-side rendered or move this component over to the client project. Okay, now I want to take a kind of skip around in here. Before we do, I do want to point out, I said before that everything in Blazor is about components. And I want to just kind of make sure that that's stuck in your brain. Everything is a component. So we have this counter, and it's got interactive auto, and we can use that as a full page because we called it at page / counter. So that's the path we've added to our route tree. But we can come over here and we can say counter. Now it's going to add this as I'm going to not take the IntelliSense here and just say counter like so, and then I'll add that using directive at the top. So this is a using directive for Blazor Web App.client.pages. So it's going to come down into the web app client project and go down to the pages namespace and look for counter. But I just said counter on my home page. Well, what does that do? What it does is it uses that counter as a component on your home page. So now the counter, WebAssembly, but it's on the home page. And I can increment that, and that's different from this counter, which is a full page. So this component can be used as a component. In fact, if I were to bring it over here, I'm going to copy this and paste it a couple more times, and I will save this, which uses hot reload, or it should. There we go. So now I have 3 counters on my page because I can use that component over and over and over again. And yes, they are separate. Notice that might be a little hard to see here. Let's zoom in. We have current count 4, current count 1, which I can increment separately, and current count here of 5. So 4, 8, 5, they're 3 separate components, but they're all on the home page. So that's how every Blazor component is built. It's first a component and secondarily a page if you want it to be, which also means that when you're building something and you create a new component and you forget to put this directive at the top at page and then put the location, and you think, well, I've created my counter, and you go to run this, well, it's going to work as a component. So we can see the component here. Notice it says server because it's a different thing now. But if I go to counter, it goes 404. I don't know what that is because the /counter route doesn't exist. We didn't tell it what the route is. I do this a lot. When I create a new component, I forget to put a route on it, and therefore I get a 404 and I try to go to it. The way I fix that is just to make sure you have at page and whatever route you want to give it, which does mean that the route here does not have to match what your folder structure is. It can be whatever you want. You can say, at counter, we could also add a second one, /Tim, because, why not? So now instead of going to /counter, which still works, we can go to counter and that works. But I could change this and go to /Tim and get a counter page. Okay, so you can add multiple page routes if you want. I would encourage you as a best practice, try to match that up to your folder structure because otherwise you'll be looking all over for what your routes are. There are some good tools. This is a shameless plug for an extension here, the Blazor extension. So if you go to manage extensions and you look for Blasm. Jimmy Engstrom created this. There's a whole bunch of quality of life things for Blazor that are here. Right click to create isolated CSS. We'll talk about that in just a minute. You can do things like see your route tree. You can move namespaces to import. You can move the code behind to a .razor, which is the other direction. We'll see that in a minute. And so many other things. Like there's the route tree right there. So you can kind of see what's in your project very easily. It's a free extension. Again, Blasm extension, BLAZM extension by Jimmy Engstrom. So with that, let's talk about code behind. We have here our counter component, and we have an @code section. This is the code behind for your Blazor page or your Blazor component is probably a better way of saying that. Now, if you have worked with old school ASP.NET, with web forms, this may feel familiar, although you'd want to see that as a separate file, right? I would encourage you as you're building components, leave it here. Leave it on your page. Now, Visual Studio, its job is to kind of figure all this stuff out. It's going to separate it out and compile it differently, obviously, when it does its work. Code is meant to be read by humans. And this is, another example of code being meant to be read by humans. Because your code is on the same page where your HTML and Razor syntax and all the rest is, well, then it's much easier to see, oh, I called that current count when I refer to it, not current counter or something else. So when you're done or you think you're production ready or whatever, if you want to, especially if your code is larger, what you can do is you can come down here to your code section and you can use the little light bulb here, control dot brings that up. You can say extract block to code behind. So what this will do is it will create a code behind for your Razor page, which actually put it interestingly up there as well as down here. But what this does is this is the same code. It's now just in a separate file for you. Now, what the Blasm extension does is it allows you to move the code behind back to the .NET Razor. Yes to all. Messed it totally up. Excellent. Doesn't always work. Actually, I think it did. It just messed up the formatting. So it's not something I do all the time, but you can go the other direction because of that Blasm extension. With Visual Studio, you can only go one direction. And that is a beta version that he's working with. So with that, I think that we can get rid of this. And we'll just fingers crossed that it still compiles because, again, changing things live. Hey, it still works. Cool. Okay, so that's the Blasm extension. That's also the code behind for your files. Now, I want to talk about a couple of things here that you might have missed that are kind of different. Let's start in here at the app.razor. So in our main project, so this is the main project here, not the client project. App.razor is the template or the web application you're building off of. So this is like your index.html, right? But it's app.razor. And in here, you'll see this @assets, and then it's a path to bootstrap.min.css, app.css, and also Blazor Web App.styles.css. So what is this @assets? Well, I'm going to show you what it does, and then I'll make it more obvious why we have it. So we're going to hit F12 here, and we're going to go over to our elements, and I will zoom in because this is too small. And if you look here let's just look at app.css. It's no longer app.css, it's app.khy, etc.css. Why is that? Well, what the assets tag does, and I can close this out now, what this assets does is it creates a unique fingerprint for this file. That way, if you were to change something in that file, that the old version of it would not be in cache. Okay, it'll basically invalidate that old version's cache, and now um, the 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 server will get the new version. That way, especially for debugging, but also if you're going to production, you're going to get the latest version of every file and not have to go, oh, we have to refresh, invalidate the cache or something else. And make sure you always have the latest version of the files when you push a new version to your server. So that's a really good benefit. You can wrap basically anything in that, and it will do that same thing. It takes a fingerprint of the file, and then it creates that extra information. So really helpful for that. Also note in here, we have right down here routes. This is where your actual components and all the rest get injected, is right here. Down here, this, basically don't touch it. This blazor.web.js, this is what handles things like the auto with server-side rendering and stream rendering and the server and WebAssembly and the auto, all the rest of the stuff is handled using that JavaScript file. That's from Microsoft. Now in the routes, real quick, so we have the routes that come from this assembly. So it grabs program. What it's doing here is grabbing a class it knows exists and says, hey, that class, give me the assembly from that class, which is this whole project. And it says load that app assembly. But they also have additional assemblies. This is where it loads the client project assembly. So we have type of client._imports, which is this file right here. It says, hey, take this file's assembly, which is this whole Blazor Web App.client assembly, and grab that whole thing as another assembly, which just safety tip here. If you were to ever say, hey, I don't like the _imports.razor being there, if you deleted that from the client, well, then this wouldn't work. So you have to point it to a different file that exists and pull in that assembly. But that brings in the two assemblies, which brings in the routes from both of those. And then it says, hey, if you found a route, then let's display the route data, but also let's use the default layout of main layout. And then the other thing it does is it focuses on navigate. It's going to focus on the H1. This is for accessibility so that when you go a new page, it's going to always focus on the H1 of the element that's supposed to be the title of your page. That way, when you hit tab, it goes from there and it goes to other components. So the main layout, that's in our layouts up here. Here's our main layout. I don't love having this bar up here that says ASP.NET Core, so we're gonna get rid of that bar. Okay, I can get rid of that. And now it's just the article where it says app body. App body, whatever page you asked for gets injected here. Okay, we also have a nav menu on the sidebar. So with that, if we run it real quick, we will have a page that looks similar, but we're going to have that nav bar at the top. Cool. One fun little thing is over in app.razor, because we're using the latest version of Bootstrap. And in fact, if you come up here to www.root and go to lib bootstrap dist, look at CSS, just look at the main Bootstrap file, we're using version 5.3.3. Because we're doing that, we have the ability to say data-bs-theme. This comes from Bootstrap. We can say dark. So doing this will apply dark mode to our site. So now if we run this application, same application, but now we'll have dark mode if it launches. Wait for it. There we go. Dark mode. Hey. So that's a fun little extra from Bootstrap. There's a whole lot more I can do there. Bootstrap 5.3 is awesome. If you don't know how to use it, learn, because it's not very large at all. It's really compacts down to, I think, like 40 or 50 kilobytes, but yet you can get a ton of stuff out of it. So learn how to use it. It will definitely accelerate your web application. Okay, so let's stop this. My machine's being a little clunky right now.
Here's a quick question.
Yes.
Can you have multiple layouts or need a hierarchy of them?
You can have both. So if you wanted to, you can have different layouts per page. And what you would do is just specify on a page, hey, I'm using a different layout. I believe it's at layout, and then you would specify what layout you're using. So this is just the default, but you can have others. And notice, by the way, this inherits from layout component base. You could inherit yours and create different levels of inheritance for your layouts. Good question.
All right. There's a follow-up question. Is there an easy way of not using a layout when there's a default registered, except for creating empty layout?
That's a great question. I have never tried it. Um, Yeah, I'd say create an empty layout, and then what you could do is either make that the default layout if you wanted that to be primary, or what you could do is you would have to just specify the default, the blank layout for when you wanted that one used. Now, you still have to have a layout because of the fact that you have to tell the page where to put the app body. So at body has to be somewhere. So your layout might just be at body, but you'd have to, just specify that in a different layout page.
Awesome. Thanks.
Cool. Okay. So I want to point out one more thing we talked. I'm skipping around here, but I want to make sure we get kind of the highlights. But in the app.razor, we have this Blazor Web App.styles.css. If you come up here and look, we have app.css, but no Blazor Web App.styles.css. Where does that come from? This is what's called the CSS isolation. So we can create CSS for a particular component and then use that, connected only to that component. So if we right click on the home.razor, we can create our own isolated CSS. Again, this is using the Blazor extension. Otherwise, you just create the same name. So you'd say, I want home.razor.css. Okay, either one will work. What this does, notice it collapses this. You have a little arrow here, but now we have our CSS that's only for this component. So I could say, I don't know, the color is sure. Let's go with something fun like crimson. All right. So now if we run this, I want you to see what this does. So you won't see, I put in the body, you won't see it anywhere here because I didn't actually put on anything specific. But if we look at our sources and we go over here to our Blazor Web App this whole thing .style.css, what we'll see is a bunch of stuff in here. But then we should see in here, you know what? I don't think it compiled into here. Nope, there it is. Body. So it says body, color is crimson, but notice that it's just for this one Razor component. It actually puts an ID here on the body. And so it's saying is, hey, just for that component, I want you to do this. And so every component can have its own CSS. And so if we were to change this to, let's look at the actual home page here, H1. So we can change this to H1. And I believe I have to make this important because otherwise I think Bootstrap will override it. But if we save this, we rebuild it, run it, we run it. There we go. What this will do is it will override it just for, notice, just for hello world. Okay, so counter doesn't get it. And I believe, if I'm not mistaken, counter is an H1 as well. Yes, H1 is counter. So even though the home page has multiple H1s, it only does the home page itself in the crimson. And that's because It's only for this page or this component technically that we get that different CSS, and that will be applied for just that component wherever it goes. Okay, so that's the isolated CSS. I would encourage you to use it sparingly. Don't go overboard with it, but it's a really great feature that all gets compacted and compiled into our Blazor Web App.styles.css, which gets built at runtime. Okay, so there are a bunch of other things we can talk about, but I did want to point out that right now we have a Blazor web app, and this is for both WebAssembly and server-side rendered and all the rest. But if you want a progressive web application that runs fully on the client, you need a separate project. Let's do that. So we create a new project here. This will be a standalone project. It won't interact with the others. I'm just going to put in the same solution file. And that is a Blazor WebAssembly Standalone app. So this is the Blazor WASM. If you hear of WASM, that stands for WebAssembly. And we're going to say, notice right here it says progressive web application. I had that checked. And what this is going to do is going to put some extra components here on our application. Now, things are a little bit different in this project type. Let's make this the startup project. So if we run this, it's going to look very, very similar. Okay. There's a page, get a little loading spinner here because it is downloading the entire thing to our client before running it. But we still have the same, counter. We still have weather, the same home and all the rest. But this was now fully client side. When you are developing, just note that this is much heavier than if you are in production release mode. That's intentional because we're connecting Visual Studio to it. So don't look at how fast it loads. Don't look at how much stuff getting downloaded to your client when you're in debug mode, because debug mode has a bunch of stuff that is going to make it run slower, and it's going to be a much larger file that goes down to your client because of the fact we want to have that rich interactive debugging experience. So you want to make sure you're in release mode and publish it before you actually do benchmarking on it to make sure that it's fast for you. With that, notice that we have app.razor, which we had app.razor down here, and that was the layout for our Blazor web app. Well, app.razor is not that here, okay? It's our router. It's what does the routing. So you might say, well, where is like my main page, my index.html type thing? Well, that's a great way of saying it, index.html. We go under www root. Well, there we go, index.html. That's your place for all the layout for your site. That's the loading spinner that waits while you are loading the page. And then your page itself is going to get rendered in here. So with that, we also notice right here where we see div app ID or ID equals app. That's where it says, oh, put your page and all the components inside this div. So if you were to change that, you would have to change what it's called. But if you come down here to program.cs, you'll see right here, root component add app. It's the hashtag app, which is the ID of that component. That's where it connects those two. So that's how it sets things up. The other thing to note is this is a progressive web application. If we were to run this and we want to install it, we can do that. So we run it. Notice it says install Blazor Web WASM app. Click there. And it says, hey, do you want to install this? Here's what it does. We can install it, puts it on the desktop. It uses this icon. Really cool stuff. I'll show you how to change that real quick. But this is can be a progressive web application. Now, iOS fights this a bit. So there's a more complicated way of installing a progressive web application. It has nothing to do with Microsoft. It has everything to do with Apple and how they don't really like PWAs. Android's a bit easier to do. Desktop's really easy, but different browsers have different ways of doing installations for it. If you go to, I believe it's pwabuilder.com, I believe it's .com, that's where you can get instructions on every browser and how to install. They even have examples of it. But that will install. Now, here's the tricky bit, again, when doing this in development mode. The tricky bit is that it uses this thing called a service worker. And the service worker is what tells it what to do for offline usage and so on. How a PWA works is it will always load the offline version first. And then it will go out to the server and see if there's a new version that it needs. And if there is, it will download that in the background. And then the next time you launch the app, you will have the new version. You won't have the new version until you reload that app. So that's not going to work for development. This is why this is online only when you're in development mode. That doesn't just mean debug mode, it even means release mode. It's only when you publish the app that it will have the offline components. The reason for this is because if you are debugging something and you say, oh, I want to change that, and you go to change it and nothing seems to happen, well, that's because it downloaded those changes in the background. You have to wait long enough for the changes to download and then relaunch your application again in order to see those changes. It's not a great experience for development. So by default, it is going to be online only. It does not enable offline support, okay? So it's always going to fetch everything online. But if you notice this little arrow here, this is for the published version. This is where they say, hey, here's the stuff to grab for offline mode. It grabs all the information you need, and it says, okay, we're going to download, if you notice over here, right up here, where it says, hey, assets to include, offline assets to include is DLLs and PDB files and WASM and HTML. And over here, you'll see things like PNG files and JPEG files and GIFs. Yes, it's GIF, not GIF, and all the rest. And you can add your own files or say, hey, I want you to exclude certain files. I don't want them to be offline capable. So that's where you can set up and change all of how your service worker works. But this only works for the published version because otherwise the debugging experience would be messy. So that's a PWA. The manifest is where you say things like what the name is, the short name, the background color, the theme color, the different icons, the different sizes, and so on. So this is the standalone WASM. Now, you do not want to try to access the database directly with a WebAssembly project. I don't have time tonight, but either in your auto counter, like here, or in your Blazor WebAssembly project, you don't want to access the database directly because your code goes to the client, which means if you have things like passwords, that goes to the client. That's not a good thing. So instead, what you want to do is use an API. That way, you're safe and secure, even on the client side. That's how you do it with Angular, React, and Vue. That's how you would do it with WebAssembly. So that does mean that if you are in the, let's close all these real quick. If you're in the web app and you want to talk to the server, if you're on a stream rendering or just a server-side rendered or a server component, not a problem. Talk directly to the database in your code. But if you're in a component that is auto or WebAssembly, you want to talk to an API instead. That way you are secure and safe even as that transition happens. It also means that when you're transitioning, you could have access to the server when it's server rendered, when it's the Blazor server with SignalR, you can have access to that component, but then you lose it when you switch over to WebAssembly, which is why you have to make sure that you are doing things that are safe for both. Okay, so that's a lot. That's a lot of stuff I've covered. I can go for another hour. I don't think we have time for that. So let's just talk real briefly. I'm going to actually stop sharing my screen and just talk to you for a minute. I want to talk through the hey, what's the future of Blazor? Is it the right call for me? Is it the right web application type? The answer is yes, yes, and awesome. So Blazor is pretty awesome. Blazor does have a great future. Blazor is a great um, project type for a lot of situations. In fact, with the Blazor web app project type, it becomes almost the only project type you need because of the fact it can grow and change over time. So as you're using it, you can start off with just a server-side project entirely, like you would have with MVC or Razor Pages, and then say, hey, I'm just going to add that one component and make it client-side. Maybe it's just server, or maybe it's an auto component. So that's a great option for you that you can grow over time without having to change your entire project. So it's very, very fast. Again, it's server-side rendered, and yet you can render specific components as client-side. That's a much lighter option for you than trying to do your whole site client-side rendered. So with that kind of conjunction of all these things, there were some glitches and some bugs, especially in .NET 8, especially around things like authentication, that pass off between server to WebAssembly. That was tricky, to say the least. But they've made some real improvements in .NET 9, and also then .NET 10 has got some more changes that make it even better. .NET 10 is not out yet. November of 2025, that's when it's coming out. So I would encourage you to check it out, and I would say probably I'm going to make a kind of a bold statement here, but I would say that MVC and Razor Pages are pretty much for just legacy projects. If you want to create a new web project in C#, I would encourage you to do Blazor. You can do all the same things as you can with MVC or Razor Pages, and yet you have that a higher ceiling to go even further and do even more by adding those components as necessary. So it's an upgrade over time thing. I think that that's probably the right call. All right. So that's kind of the future of Blazor. I think that Microsoft is heavily invested in it. Microsoft is kind of pushing that as the way to go forward as well. I don't do everything Microsoft says for sure, but I think this is a pretty good call on way to do web right. Okay. So with that, I'll open up for questions. If you have any, we can go from there.
Awesome. Thank you, Tim.
Yep,
I
I'm just
greatly
jumping in the chat,
appreciate
so you
it.
can go ahead and ask those questions.
Okay. Yeah, I think the one question remaining that's not been addressed yet is what kind of applications are not a good fit for Blazor?
That's a great question. Well, legacy applications. If you've got a legacy application that's MVC, there's no reason to move it over. If it works, keep it. But personally, I have found with the new Blazor Web App that it pretty much handles anything that I need. So I don't have to, make a decision now about how my project is going to look or how it's going to work. So again, with probably .NET 9, I wouldn't say if it was even .NET 8 that Blazor Web App is the way to go for everything. But with .NET 9 especially, I think that Blazor Web App is the right call for all web applications going forward.
I can, if I can jump in, I can tell you from the product team, like on the ASMIC core team, Blazor for .NET web UI development, that's where our investment is. Like that's where we're doing innovation, that's where we're adding features and making significant improvements. MVC and Razor Pages for .NET web UI development are still absolutely supported and will continue to be so. And we have lots and lots of developers that use those frameworks to build their UI, but it's not really where we're like innovating. You'll be able to upgrade to .NET 10 and get all the new .NET 10 platform features for your MVC and Razor Pages apps, but we're not like adding features and new things specifically to MVC or to Razor Pages. We're focusing that effort on Blazor, and for new development, we would absolutely recommend Blazor for .NET web UI development. Now, I would also say though that there are some cases where using JavaScript for .NET for your web UI might still be the right call. Like if you're in an app where you need to have a richly interactive experience and you are hypersensitive to download speed, like you need to have a rich client side experience and you need it to load, in sub 100 milliseconds or whatever, then it might behoove your investment, your additional work to actually write the client side pieces in JavaScript. Blazor's not trying to be the fastest, smallest framework on the planet, obviously, particularly on the client. And many of our Microsoft apps that are like global scale, consumer facing, that are sensitive to that initial load time performance are absolutely implemented that way. We have a bunch of React code at Microsoft. But for a lot of development where that doesn't matter much, then Blazor is where it's at. It can just be so much more productive by implementing the whole app in full stack C#. So that's an option too. Front-end JavaScript still supported with asmk core as well, and there's lots of good options there if you really can afford having a separate front-end JavaScript team as well as a back-end .NET team, or you're just good at both. But if you want to save time and just write it all in C#, Blazor's pretty awesome.
I'm going to jump in here real quick too. Some old man advice. So I've been around the block a few times, and one of the things that whatever project type you're using, whatever framework you're using, whatever code you're using, I hear people talk about how slow it is and how it's bogged down, all the rest. And 99 times out of 100, it's because you have not learned how to optimize that code. So before you change off of whatever you're on, I would encourage you to look at optimization and make sure that you're actually writing good code first. Because yeah, as Dan said, if you want the sub 100 millisecond load for a massive site, sure, maybe. But oftentimes I'll find that, you can get that same speed or close to that same speed with your site, because not everyone runs a Google or Microsoft. But you can write that in Blazor and get that same speed. So just make sure you optimize your code before you look at the framework as the problem.
Yeah, fair point. All right, another question that's come in is, what do you think about Blazor with React? How does that behave together?
I'll let you jump on that, Dan.
So they're both component models with DOM diffing algorithm systems. There are ways that you could compose them. Like I believe there are ways that you can implement a custom element, like a standards-based custom element, using React, and then you use that thing in a Blazor app, just like you would any other custom element. Like Blazor is just HTML and CSS, and then some CSS C# logic, right? So if you want to use web components and custom elements, you can absolutely do that, and those custom elements can be implemented in whatever you want, and that will compose very cleanly with Blazor's DOM diffing algorithm. Where you can run into trouble is where like if both frameworks are trying to keep track of the DOM and they're both like, modifying the DOM and like Blazor doesn't know that React decided to hop in and fiddle with some DOM elements, then Blazor will lose track of what the state of the DOM is and things can get confusing. So I don't normally see people compose them very much. There are facilities in Blazor where you can add JavaScript libraries to your Blazor app and interact with them through JavaScript interop APIs. Like you can call from C# into JavaScript and from JavaScript back into C#. And maybe there's like a React component that you want to throw into your Blazor app using like maybe the custom element pattern that I mentioned earlier. But honestly, I haven't seen a lot of people do that. If other people on the call have had success with that, I'd love to hear about it. But I would suggest you probably should just pick one. If you're looking for components for Blazor, there are lots of component libraries out there from all the big control vendors and open source offerings. We have the Fluent UI Blazor components, which I saw mentioned in the chat, with like data grids and things. So we have a fairly rich ecosystem as well. So I would look for what's available in the Blazor ecosystem first before I try to like blend the two systems, because I think you'll just end up with a lot of extra complexity. Conversely, if you have a React app and you're like, oh, but I started with React and I really wish I'd used Blazor, you can do the opposite, where you can render Blazor components inside your React app as custom elements and start to sort of maybe even start migrating, like whittling away at your React code and replacing it with Blazor so that you can live the dream of writing everything in C#. That is also possible. But again, there's some complexity involved with doing that. Best bet is probably to keep those two worlds separate, is what I would generally recommend.
That is a good point. So another interesting question has come in. Can the Blazor WebAssembly DLLs be disassembled if people want to see their code?
Yes.
Absolutely.
Yeah, the other comment that I saw was never trust the client.
That's right. It's public code. We downloaded it in WebAssembly. It's public code. Yeah, this is one of the things that some people get bitten by because they're so used to having their code only live on the server, and but now you can just use your .NET assemblies in this Blazor WebAssembly app, and you just start throwing in dependencies, right? You have some big giant assembly that you've like just amalgamation of various server functionality that you've built up over the years, and you're like, oh, I can just use this in my Blazor WebAssembly app now, and you downloaded this giant thing. So there's a couple issues with that. One is, yeah, the people can absolutely see that code. They'll download it and they could decompile it and see what's there. So in general, like I saw there's something about obfuscation. Like I wouldn't even bother that. You should think about the code that goes to the client as public code, just like you would with JavaScript. That's the way you should think about it. It's not, it shouldn't be anything that's secret in that code. You also want to make sure your dependency graph is as small and clean and and well factored. Like don't throw some giant server only dependencies into your Blazor WebAssembly app because that now all has to be downloaded. And I've seen Blazor WebAssembly apps that made me so cry because they had like 20, 30 megabytes of random assemblies that they threw in there because they just weren't used to the idea that this is now a client app. Like you're downloading these things at the wire. So you keep your dependency graph for the client project. That's why it's a separate project, honestly, is to help you know that this is a separate piece. It's going to be downloaded as small and as clean as possible. Factor things so that server stuff stays on the server. Only things you want to be downloading is the what's needed on the client. And Tim, if you have any more stuff to add on that, sorry, I talked for.
No, you're good. I would highly encourage you to put everything possible behind an API. That's just good advice for development in general, especially to think about upgrading and changing your user interface over time. Is if it's behind an API, then you can call it from your server and you can call it from your client. It's not getting downloaded to the client because it's just the API call. That way you can make sure that you're using the same code and all your libraries, like Dan said, but they're all on the server. You're not bringing down all that to the client. You're just bringing down the results of that call for all its calls, which also means that if you're going to say, hey, I don't want to use Blazor anymore, I want to use React or something else, well, that's the same API. So you're still good. And if you decide, hey, I want to have a .NET MAUI app as well, you still have the same API. So it allows you to be a lot more flexible. It makes sure you protect your desktop apps as well, because using an API means no more user secrets on the desktop, which can be intercepted as well. So yeah, obfuscation is not the answer. Trying to have some kind of even encryption is not the answer because the user owns one end of that pipeline. So therefore, it's going to be at some point in clear text, and it's going to be at some point exposed to the user if they know where to grab it. So just treat it as public code like you would React Angular or Vue.
So never send the intellectual property down to the client.
Correct.
Yeah. All right. Another question is there a way to tree shake the dependency tree to avoid fatware in WebAssembly? I see
Yes.
the heads nod. Yes, there is a way to do it. All right.
We when you publish the Blazor WebAssembly app, it will get trimmed by default. Like we will use the .NET has supports trimming and we'll run the trimmer over the app. But thing to note is that we use the partial trim mode. So that means that assemblies have to say that they support trimming. They have to have been, someone has to have gone and done the work for that assembly to annotate and say like, this is a trimmable assembly. I've gone through and addressed all its warnings and it's using the analyzers and stuff so they can be trimmed. The reality is that a lot of people's dependencies have not been set up that way. So you often, you pull random NuGet packages into your Blazor WebAssembly project, and you have a bunch of assemblies that don't support trimming, and then they don't get touched. But your application code will get trimmed, and the Blazor framework and the .NET framework libraries, those will all get trimmed. I think Tim, you were talking about that. Like during development, if you look at the browser dev tools and look at the download size of your Blazor WebAssembly app during development, it will look big because it hasn't been trimmed yet. It'll be like tens of megabytes. But when you publish it, we run the trimmer and we pre-compress everything, and it shrinks way down to like 1 or 2 megabytes in the default case. So yeah, it will get trimmed, but in the Blazor case, your assemblies have to support trimming for that to work. We have talked about switching it all the way to full trimming, which is what we do for like native AOT, where we just say, you know what? We don't care if you think you support trimming or not. We're going to trim you anyway. But I think even in Blazor, we have a few cases where that's been problematic. It's a pretty heavy hammer, so we're not quite ready to switch that flip that switch. But at some
Well,
point, we'd like to.
if you write certain code too, that'll cause some problems with the trimming, correct? Like the reflection is an issue.
Certain reflection patterns can actually work with trimming, but there are patterns that certainly won't, and yeah, you have to be careful. And there are correct ways to write libraries that will work correctly with trimming, like using source generators and all this type of stuff. Um, yeah, so it does limit what you can do in your code as well if you do full on trimming.
That was a lot of great questions. Any other questions? You're more than welcome to come off mute and ask or post them in chat. We'll give just another minute. In the meantime, Tim, thank you so much. That was great. I
Sure.
really appreciate this.
I've got a part 2 if you ever want a part 2, because we've got so much more to cover. Blazor's awesome. If you haven't heard already, Blazor is amazing. I highly recommend you learn more, and there's a ton more to learn.
That is awesome. Yes, I will take you up on that. Yes, part 2 off, please. Yes, off is definitely its own beast.
That's a whole part 3.
No
It's a whole series. We'll go all summer.
All right. Well, I will stop the recording. And thank you all for coming out tonight, and more than welcome to stick around for the after party. And Tim, thank you again for the presentation. It was awesome. Thank you.
Anytime.